Welcome to Homework Lib.
So in this question, we have silicon, and then we are told that when the light is emitted by a silicon, can detect. So the light that a silicon photocell can detect is at the wavelength of 1.1 micrometer. And we want to know that what is the energy gap in electrovolts between the valence and the conducting band. And we know that usually if a silicon can detect or can absorb this energy of a photon of 1.1 micrometer, then that means the amount of energy carried by this photon is exactly the same as the amount of energy that the silicon has between its valence and conducting bands. Because quantized energy, that is how it can detect the light, is if the energy happens to match the energy gap inside the silicon. So what we know from that is that 1.1 micrometer photon carries the exact same amount of energy that is required to go between a valence band into a conducting band. So the amount of energy, delta E, we can go back to the de Broglie equation. Says how much energy does a 1.1 micrometer photon carries is given by delta E equals hc over lambda, where lambda is wavelength. So, and we want to have everything in electrovolts. H in electrovolts is 4.136 times 10 to the negative 15 electrovolts times second. And then c is the speed of light times 3 times 10 to the 8th meter per second. And then lambda we are given is 1.11 times 10 to the negative 6 meter. This gives us an amount of energy of 1.12 electrovolts. So this is the energy band we are looking for. Second question asks, why is silicon opaque? Well, this is a relatively easy question because if 1.11 micrometer is the photon that it can detect, it is also the photon that it can spontaneously emit. And 1.11 micrometer, how much is that in nanometer? It's 1,010 nanometer. And we know that the visible range is roughly 200 to 700 nanometer, or even 300 to 700 nanometer is a visible light. So 1100 nanometer is obviously not visible light, it's infrared. Because of that, silicon will not be transparent. It's opaque because we cannot see the light that actually goes through it.